Hello there, welcome to this video on 14-6, and in this video we are going to model periodic phenomena with trigonometric functions. And just plain English, we're going to go ahead and look at graphs of some trigonometric functions, and we are going to model them with either a sine or a cosine function that we can generate based upon its graphical features. Now, we are going to be having context, some word problems that go along with these pictures just to help us kind of make sense of this. But what we're going to be mainly doing is just looking at some graphs, determining certain features, amplitude, period, midline, maybe if we have some phase shift, and just writing a function for it. All right, so let's go ahead and check it out. So things that move in a circular or wave-like motion, periodic phenomena, can be modeled using either a sine or a cosine function. The wave-like shape of the sine and the cosine functions have a crest where the maximum occurs and a trough where the minimum occurs. And what we have here is some academic vocabulary. Maybe you want to go ahead and highlight or underline these words. Crest, that's a maximum, and a trough, which is the minimum, right? Peaks and valleys, that's a periodic phenomena. Okay, and just some features that we're going to use in this lesson, using the crest and the trough, is that halfway between the crest and the trough is the graph's midline, and this makes sense, right? Halfway between the maximum, and you can kind of see this here. So here is the crest, right, and here is a trough, right? Well, halfway between the max and the min has to be the mid. Okay. The distance that the crest rises above the midline, or the distance that the trough falls below the midline, is called the amplitude. And again, this makes sense. We know, right, for amplitude, that the distance from the midline to either a maximum or down to a minimum, that is our amplitude. Okay, and lastly, it says the horizontal distance between the crest and the trough is half the period. And this also makes sense because if I have a function and I go from the maximum down to the minimum, right, well, to complete one whole period, I have to go back up to the maximum, okay? And generally, that's half the function. So that would make sense, right, that is half of the period. Okay, so when modeling periodic phenomena, either a sine or a cosine function can be used, since performing a horizontal translation of pi half units on sine produces cosine. This is also true vice versa. You could go from cosine over to sine. But generally, if it's not kind of specified, we can go ahead and use whatever type of function we want, either sine or cosine. However, there are some things that kind of like designate some telltale signs, if you will, about what function we're going to use, okay? And that is that if the y-intercept is on the midline, that is going to be a sine function, okay? That makes sense that we're going to be using the sine function. I'm just going to underline sine. If it's y-intercept's on the midline, we're going to be using sine. Okay, now same idea. If the y-intercept is either at a maximum, which is a crest, we just learned that word, or at a minimum, right, at a trough, okay, we're going to use the cosine function, right? And one thing that you can go ahead and kind of also infer too is that if your y-intercept is at a maximum, you know that your a value is going to be positive. Okay, if your if your minimum is at a trough, right, or your y-intercept is at a minimum or a trough, then you know that your a value is negative. Okay, and those are just some tricks. If it's neither, then what we're going to have to do is some phase shifts, and this isn't going to be the case today. Today we're not going to look at any case where we have phase shifts. You're welcome. But it is possible to go ahead and kind of analyze, okay, where is my crest, where's my trough, and then I have to generate a function using a phase shift that accurately kind of models this, all right? Okay, so what's kind of our procedure or our steps for these problems? And this is something that maybe in your notes you want to go back to throughout the lesson. But here are our steps to write either a sine or a cosine model of these general forms, right? A times our function of 1 over b times x plus k. All right, so step one. Step one is determine the function that is used, sketch a graph if necessary. Most of our problems today a graph is going to be given, but that won't always be the case. Sometimes we'll have to go ahead and sketch a graph, all right? Okay, step 2, what we need to do in order to go ahead and write a trigonometric function is we need the midline, which is the value of k. And there's a couple of ways, like we said, we can go ahead and calculate this. One way is just determine, okay, what's halfway between the maximum and the minimum values. Next, what you have to do is you have to determine the amplitude, right? And if you know the midline, you know a max and a minimum, then you can easily go ahead and calculate your amplitude, right? But you do have to determine, is your a value out front of your function positive or negative, and that will be determined based upon the function, okay? Part B, or sorry, step 4, I don't know where I got part B from. Find the period. Okay, you have to go ahead and determine how often is my function going to go ahead and repeat itself, right? And that will help us do step 5, which is determining the value of 1 over b, because period is 2 pi over 1 over b. And then lastly, makes sense, write the function, right? Go ahead and write the function that it models. Okay, so now that we have a plan, let's go ahead and look at the first example. Here we go. All right, so this problem says, as a gear spins, the height of a point on its edge above or below the horizontal diameter of the gear can be modeled by the graph shown. Write a function that models the situation. Okay, so first of all, what type of function are we going to use? And just looking at this, I have a y-intercept that is a minimum. Okay, well, if it's a max or a min, then I'm going to go ahead and use cosine. So I'm going to say use f of x is equal to a cosine of 1 over b times x plus k. Okay, so that's the function I'm using. Step 2, I want to go ahead and determine the midline. What is our midline going to be for this problem? And in this case, what you can see is that your minimum is here at negative 0.25 and your maximum is here at positive 0.25, and the units are feet. So you know that your midline is centered at 0. Y is equal to 0, which this implies that our k value is equal to 0. Okay, and that will be important. All right, next step. Next step, I want to go ahead and determine the amplitude. Okay, what is the amplitude? Well, we know just from looking at this, right, from the midline down to the minimum, that the amplitude is 0.25. Okay, so I know that it's 0.25. But notice that I'm starting at a minimum instead of a maximum. So what's going to happen is that we have some x-axis reflection, meaning that our a value is equal to negative 0.25, right? Because of the x-axis reflection. All right, next step. What is our period? Okay, and again, you can just go ahead and pick any point on the graph. I mean, I can start here with my minimum, right? This point, and then I find the minimum again, and that distance, right, was 10. Okay, so I know that the period is equal to 10. Very, very easy. Another way to go ahead and do that is you can go ahead and identify, okay, again, to use some of that language that we're talking about. Here's our trough, right? Here is our crest, okay? And that distance is 5, right? And we know that the distance between the trough and the crest is half of the period. So period is 10, okay? All right, moving on. Next, we know that the period, can't spell, the period, which is 2 pi over 1 over b, is equal to 10. So if I want to go ahead and solve this, I can multiply both sides by 1 over b. So 1 over b times 10 is equal to 2 pi. And then if I go ahead and divide both sides by 1 over b, why would I do that? I just did that, Schwarberg. Divide by 10. I knew that. Okay, so 1 over b is equal to 2 pi over 10, and we can go ahead and reduce by 2 top and bottom, meaning that our 1 over b value is pi fifths. Okay, so hey, I have my midline, I have my a value, and I have the period, or sorry, the 1 over b value, right, which helps determine period. So what we can do is go ahead and write our function. So here's step 6. What's your function? Well, our function is f of x, and really it could be any function. It could be g, it could be r. F of x is equal to negative 0.25 times cosine of pi fifths x, okay, plus 0, right, which we don't write because that's trivial. And there is your function. All right, so pretty straightforward. It's nice they gave us a graph, and those are very straightforward, simple problems. Okay, here is a practice problem. Please go ahead, pause the video. I want you to try this one on your own. All right, hopefully you tried it. Hopefully you use the steps 1 through 6 to kind of break it down. Here is the solution for this one. Again, because the y-intercept is a maximum, you're going to use cosine. Your midline, it's centered at 0, so k is equal to 0. The amplitude is 2, right, from your midline to your max, and from your midline to your minimum, so your a value is 2. Your period is equal to 4, and so your function is this. F of x equals 2 cosine pi halves x. All right. Hey, we have some questions here that we want to ask you just to get you thinking. How can you determine the amplitude of the function just by looking at its graph? Like, what did we do? I want you to take a second, pause the video if you need to. Go ahead and write a response, and then I'll show you the answer. Okay, hopefully you wrote a response. And I mean, here's how you determine the amplitude, right? You need to find half the vertical distance between the max, which is a crest, and its minimum point, the trough. And just to kind of visualize this, I'll use pink. Why not? So here's the crest, right? And here's your trough, crest, trough, and halfway between it, right, is your midline. Okay, and so that's very, very intuitive, right? Okay, another way to do it, right, is find the distance from the midline to either its maximum point or its minimum point. And I would say that that's the easiest kind of thing to do, right? Very straightforward. Okay, next question. It says, how can you determine the period of a function just by looking at its graph? So pause the video, take a second to mull this over, write a response, and then I'll show you the answer. Okay, hopefully you did this. Here is the solution. How can you determine the period? Well, determine the horizontal distance of one cycle, and that's very easy. You can pick a max, a min, a mid, a minimum, and you can just find that one cycle. Otherwise, you know, you can go ahead and do what we talked about with the crest and the trough. Well, half of that, right? Half of that, that distance is half of your period. So very straightforward. Okay, next example. Here we go. All right, so notice on this one we don't have a graph, so we're going to have to go ahead and generate that, and this problem is going to give us some key information to help us do that. Okay, so as a tuning fork vibrates, it creates fluctuations in air pressure. The maximum change in air pressure, typically measured in pascals, is the sound of the wave's amplitude. Okay, so at 0.001 seconds, a sound wave crests at 4 pascals. All right, and at 0.003 seconds, the sound wave troughs at -4 pascals. Okay, so it looks like they just gave us our max and our min. Okay, and they want us to go ahead. Here's the question. So I often highlight the question in a different color. Write a function that models this situation if the sound wave is measured beginning at 0 pascals. Okay, So what we want to go ahead and do is generate a graph. So what I'm going to do is draw a y-axis and an x-axis. Okay, and I'm just going to kind of take the information that they give us. So they say at 0.001, okay, so I'll just say this is 0.001, and this is seconds. Okay, it says a sound wave crests at 4 pascals. So this is 4, right? And then this is measured in pascals. Okay, so right here is our maximum. Then they say at 0.003, the sound wave troughs at -4 pascals. Okay, so you can kind of see, right? This is, well, halfway in between is going to be our midpoint. Okay. So starting at 0, we're going to have a graph that looks like this. And kind of this distance here is 0.1, so we assume that this goes back at 0.004. Okay, so there is kind of our graph. And what are we going to use? Are we going to use a sine or a cosine function? Well, again, like you said, the y-intercept, right, is at the origin, so this is going to be a sine function. Use f of x is equal to a sine of 1 over b times x plus k. Okay, all right. Step 2, what is our midline? Well, just looking at this, it's centered at y equals 0, so midline is y equals 0. Okay, so that implies that k is equal to 0. All right. Next, what is our amplitude? And hope you can see that the amplitude is 4, right? And our a value is going to be positive. So a is equal to 4, right? Because we don't have a reflection. All right. Next, what is our period? And for this one, I mean, just the information that they tell us that the crest is at 0.1 and that the trough is at 0.3. Okay, so that tells us that distance is 0.002, which is going to be half of our period, right? So period is equal to 0.004. And again, the way I'm calculating this, right, is distance between trough and crest is 0.002. So to get the period, right, we just multiply by 2. We double it. Okay, and also too, I mean, just visually you could see this, right? But based upon the given information, that's how I calculated it. All right, next we need our 1 over b value. What is the 1 over b value? Okay, so remember that period is equal to 2 pi over 1 over b. And in this case, this is 0.004. All right, so we'll multiply both sides by 1 over b. And then we'll go ahead and divide both sides by 0.004. Okay, and we get a 1 over b value, 2 pi over 0.004. 4. And if you wanted to reduce this, you can, right? I'm just going to reduce by 2, 0.002. I guess if you wanted to go ahead and multiply by, what, tenths, hundredths, thousandths, you could multiply by 1,000, so 1,000 pi, but this is fine for now. Okay, so 6. What is our function going to be? Well, f of x, right? And we want a function. We don't want a equation. An equation, they say a function, so we need to use function notation, f of x. So f of x is equal to, our a value is 4 times sine times pi over 0.002 x. You can put the x in the numerator if you wish, and that is it. All right, so there you have it. Okay, here is a practice problem. Please go ahead, pause the video, and try this one. Make sure that you, at the start, generate a graph, just a simple sketch of what this situation looks like. All right, hopefully you have paused the video. Here is the solution. And here's kind of what your graph could look like. Since your y-intercept is on the midline, you have a sine function, and it is centered at y equals 0, so that's your k value is 0. The amplitude is 3, since the maximum is first reached at 3. And you know that your a value is positive, right? Since it's maximum first besides a minimum. All right, and then if you wanted the period, you could just go ahead and find out, okay, what was the distance between the max and the minimum, right? That distance between the crest and the trough, and then you double that. So the period is 0.028, okay? And then using our calculations, we find out that 1 over b is pi over 0.014. All right, so here is our function. F of x is equal to 3 sine of pi over 0.014 x. All right, here is another practice problem. Go ahead, pause the video, and try this one. Right, and here is the solution. All right. Okay. Something to note about this problem is that your a value is negative because you're starting out at a minimum. Right, so you obviously know it's cosine, and that your a value is going to be negative because you're starting out at that minimum. All right. Okay, another question. How can being given the crest and the trough of a function help you find its period? Please pause the video, go ahead and answer this question. All right, hopefully you paused it. Here is the solution. Well, that horizontal distance between the crest and the trough is half the period. So in order to find the period, you just double that. Straightforward. Okay, last example that I have, here it says, water turns a wheel at an old mill. Okay, at time t in seconds, sorry, I want to get my highlighter right. At time t in seconds, a point on the wheel has a height h relative to the stream into which water falls. Okay, so they say in 6 seconds, a point on the wheel travels from a maximum height of 35 feet, okay, to a minimum of 5 feet. Write a function that models the situation, okay, where if the point starts from its maximum height, okay. All right, so first thing that we need an image. So I'm going to go ahead, I'm just going to start my graph here. So here's my y-axis, and this is in feet. And then I have the x-axis, and this is in seconds again. Okay. So what they say is that the point is going to start at its maximum height. And really, actually, my graph is kind of wrong here. I'll put it lower, right? Because they say starting out at a maximum point here, okay? And that was at maximum height is 35 feet. So that is at 35. Okay. All right. And they also say, too, that this starts out at a maximum, and then in 6 seconds, it goes to its minimum. Okay, so I know that at 6 seconds, so this is going to be 6. Okay, it's going to go down to its minimum, which I'll say this is at 5. Okay, so all right, that's the given information that we have right now. Okay, and so let's go ahead and just kind of start dissecting this. So what type of function are we going to go ahead and use? Well, we're going to use cosine. And that is because we're starting out at a maximum. Next, we want to go ahead and determine our midline. But note that that is not given here. I mean, you can kind of infer, right, that our minimum is 5, our maximum is 35. So right in between there is going to be the midline. But what I like to do here is I want to go ahead and jump to the amplitude, and we'll go ahead and kind of come back to this. So amplitude, right, this is the maximum minus the minimum cut in half. So since our max is 35, our min is 5, that's going to be 30 divided by 2, so that is 15. Okay, so I know that our amplitude is 15, and I know that it's positive. Or sorry, a value is positive because we're starting at a maximum. But what this really does is it now allows me to determine the midline, because I know that amplitude to the midline, or sorry, the distance from the midline down to a minimum, right? That's our amplitude. So if I just go ahead and take 5, right, and I go up 15 feet, this is going to give us our midline, okay, which is going to occur at 20. So midline is y equals 20, okay, which implies that k is equal to 20. Right, and so really this kind of helps us out. We know that now, right, our graph, that's ugly. We know that our graph will look something like this, right? This is 9, and this is 3, okay? All right, next, what is our period? Well, a couple of ways you could do this. From the crest to the trough is 6 seconds, right? So we know that the period is going to be, right? So here's that horizontal distance from the crest to the trough. That's 6. So I know our period is going to be 12 seconds. Okay? Since we know that, now we can calculate the 1 over b value. Which implies that 1 over b is equal to 2 pi 12ths, which is pi 6. Okay? All right, so now we're done. Now we have our function. All right, step 6. We have f of x is equal to, our amplitude is 15. We have a cosine function. Our 1 over b value is pi 6. And we have a midline of 20. And let me just go ahead and double check my notes. And that is it. All right, so that's the last example. I do have one more practice problem. Here you go. You can go ahead and pause the video and try this one. All right, hopefully you paused it. Here is the solution. Okay, so this is a sine function because we're starting out at a midline. Our midline is going to be halfway between the min and the max, so that puts us at 30. And then the amplitude is 20. Our period is going to be 32 seconds with a 1 over b value of pi 16ths. So we get h of t down here. All right, that is it for this lesson. Now you should know how to go ahead and apply a trigonometric model to a given situation. All right, catch you next time.